Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 10.1 on graphing square root functions. And essentially, this lesson comes down to what we did in previous chapters, where we look at parent functions and then we learn how we can look at the equation or modify the equation to move the graph around to transform the graph into slightly different shapes and positions. Okay, so let's take a look at what a parent function looks like, and it looks like this, where f of x equals the square root of x. And how do we get this shape here? Well, let's take a look at our graph here. So if x is 1, well, let's even start before that. That'd be even probably better, because most of our graphs always start at 0, 0. Our parent function is 0, 0. If x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is 1. Notice that also works for exponential functions and linear functions and quadratic functions, this 1, 1, 0, 0 thing. Okay, here's where things change. Instead of doing 2 and getting the square root of 2, which would be some kind of weird number, let's just look at perfect square numbers like 4. The 4 is a perfect square number, so we have a perfect square root here of 2. And then way out here at 9, we have 3. And of course, we have to go way out to 16 before this graph gets up to 4. We have to go way out to 16 over there somewhere. But that's how we get this shape. And before we move on, let's talk about domain here. So of course, in the parent function here, the domain is x is greater than or equal to 0. So we're only talking about positive numbers here. And of course, the range is y is greater than or equal to 0. And again, one kind of clue for that right now, because we haven't changed anything, is that this thing always refers to the principal square root. So we're not taking the square roots. We're looking at the principal square root of a number. Okay. Transformations. These are all basically the same as we've done before, so you should be used to these by now. When we subtract or add directly to the x, we're going to get a horizontal translation. And again, it's backwards of what we're used to, what you might think. You're used to this by now, but if we subtract 2, the whole thing shifts 2 units to the right. If we add 3, it goes to the left. So this is the one that's kind of, it goes against kind of what you think it might be, right? Vertical translations is when we add to or subtract from the output, right? So after we've done the thing, if we add or subtract to it, then we're going to move the thing up or down. That's our vertical translation. Reflecting over the x or y axis, if we multiply by a negative number, the output by the negative number, this is the output, of course, we're going to flip it over the x-axis. If we multiply the x before we take the square root, we flip it over the y-axis. Horizontal, stretch or shrink. Same thing. If we multiply the x before we take the square root by a number greater than 3, in this case, we're going to get a shrink by a factor of 3. And in this case, we multiply by 1/2, we get a stretch by a factor of 2. That's the horizontal way. But mostly we're looking at vertical. Most of the examples we've seen in the past are vertical. So we take the output, and if we multiply by a number greater than 1, we're going to get a stretch. And then if we multiply by a fraction, we're going to get a shrink. We haven't done a lot of the horizontal stretch or shrinks in the past, but here it is for you anyways. Okay, so those are all basically the same. Let's take a look at some example problems here. It says, describe the domain of f of x equals 3 times the square root of x minus 5. So first thing I want to think of is my parent function here. I'm going to just kind of plot my points here. I can kind of draw there's a rough sketch of the graph. It's not perfect, but let's take a look at this. So the -5 here, again, before we take the square root, means we're going to have a horizontal or horizontal translation what, 5 units to the right. So this point becomes this point. So now my graph is going to be something like that. And then I'm going to multiply the output by 3. So it's going to be a vertical stretch by 3. So now the whole thing is going to be kind of like stretched upwards this way. Okay, so what's my domain? My domain is going to be, from this point over now, domain is going to be x is greater than or equal to 5. That's my domain. My range is still the same, but we're not asked about that at this point. So this is x is greater than or equal to 5. Okay, so next we're asked to graph this f of x equals the square root of x plus 3. So in this case, this is going to be a vertical translation up by 3 spaces. So again, just kind of sketching in that parent function here for 293, something like that. That's our parent function. If I'm going to shift this up by 3 spaces, then everything moves up 3 spaces. So 1, 2, 3. This one goes up 1, 2, 3. This one goes up 1, 2, 3. And this one goes up 1, 2, 3. Okay. So there's my new graph. There's my graph of the square root of x plus 3. And now the range of the function is what? Now I'm starting here, and this graph keeps moving up, right? It doesn't move down. So in this case, y is greater than or equal to 3. That's my my range of this new function here. Okay, straightforward so far, pretty straightforward. Again, things that we've already seen. This graph is going to be, it says to compare it to this graph here. Now, obviously, we can look at this and say we're going to have a horizontal translation 2 units to the right. So I'm just going to make some notes to myself here. Horizontal trans 2 units right. And since we're multiplying the whole thing by a -1, it's going to be a flip over the x-axis. Okay, so again, let's just kind of sketch in that first graph here. 1, 1, 4, 2, 9, 3. Okay, so we're going to shift it 2 units to the right. So it's going to look like this. It looks something like that. And then we're going to flip it over the x-axis. So now it's going to actually be down here. Something like that. Okay, so we're going to compare it. But the comparison, again, we're just going to talk about these things that we can actually look without even looking at the graph. We can say to compare this to the parent function, we have a horizontal translation 2 units right, based on this, and a flip over the x-axis. And I say flip, but I'm sorry, I mean reflection, right? Sorry. I'm still getting used to some of these new words too. Reflection over the x-axis. Okay. We're going to let G equal this. This says describe the transformations and then graph it. So I'm not going to go through the graph on this one. Let's just talk about the transformations here since we have so many. Okay, so we're going to have a horizontal translation. But 3 units. And again, it's reverse of what you think. It says negative, but for these horizontals, it's the other way. 3 units right. We have a vertical translation. 2 units down. And we're multiplied by a negative number, so we're going to have a we're going to have a reflection. Sorry about that. We're going to have a reflection over the x-axis. And because it's not just a -1, it's a -2, it's going to be a vertical stretch. Okay, let's do that one in black. This one's the vertical stretch by a factor of 2. So all these things we've done before, but we're just applying it to a different shape right now. So that one had a lot of different things that I won't do the graph on this one, but that's it for now. Stay focused like Katniss. We've got important things to take care of. Stay focused like Katniss. How's she holding that arrow? It's behind her hand. That's weird. Is that weird? Anyways, stay focused. Let's hit our targets. This is a short chapter, a lot of function stuff, and take care, and I'll see you in class. Bye-bye.